Okay, forget about the quiz just now. Okay, you have another quiz next week. Okay. Now, we continue this one. Last time we stopped here, right? Last time after you have done the first question, then we stop. So today we continue. Correct? Question number 2. On the line. Okay. So now we want to solve this using Laplace transform. Okay. So we Laplace transform every single term. Try to write out the Laplace transform of every single term. Solving a differential equation using Laplace transform is coming up in your final exam every year. Every year. If you look at your past year question, you can always find solve a differential equation using using Laplace transform. Okay, x double prime. Double prime is n is 2. Okay, n is 2. So you will have s squared. Okay, s squared. X capital in s. Okay, followed by this one next will be s. And this one next will be lowercase of x in 0. And next, no more s. Okay, because s to the power 0. Okay, s to the power 0, which is 1. And x will be x prime. Okay, x prime is 0. So this is for Laplace of x double prime. For x prime, okay, this is minus, okay, minus, and we give a bracket. Okay, bracket. N is 1. Okay, x prime n is 1, so you have s, x in capital in s, minus, no more s, like x in 0. Okay, lowercase of x 0. Okay, x. This x is not a derivative. Okay, it's not a derivative, so you just write the capital X in s. Laplace 0 is 0. Okay, so next what we do, we substitute the initial values into here. X0 is 2, x0 is 2, and x prime 0 is negative 1. Okay, simplify. Okay, minus 2x minus plus 1 minus x in s minus plus 2 minus 6 x in s equals to 0. Okay, then we factorize the x in s. And simplify those terms without x in s and move them to the right. Okay, so you have x squared minus s minus 6. Then, okay, you have minus 2s. When you get a positive 2s, 1 plus 2, you get a plus 3. When you move, minus 3. Okay, we just want this to stay on the left. We want only this x in s stay on the left. So you just try to rearrange. Okay, rearrange so that we get this. This one, this is multiplication. When we move, it will be division. Then inverse Laplace. Inverse Laplace to get this. This is the result that you want. Okay, because your differential equation is this one, right? X. Okay, x. So your final answer will be in this x, lowercase of x in t. So to get this, we will need to apply inverse Laplace. Inverse Laplace this function. Okay, but this one, if you want to inverse Laplace this, so you need to complete the square. Okay, so you can try to complete the square for this one first. S squared minus s minus 6. Okay. So you have s minus 1/2 minus the square of this 1/4. Continue with this minus 6. So you get this. This is 25/4. Okay. So meaning that this one, after we complete the square, we get this. Minus x minus 6. And wrap this off. And continue here. Okay, so your xt If we have changed the denominator into this s minus half square minus 25/4. So next step later, we have to apply the first translation to take out the negative half. Okay, if you want to take out negative half from this s minus a, make sure all s in the same form. So you have to create the s minus half for this s. So 2s minus 3. Okay, before you take out the minus half, make sure all s must be in the form of s minus a. So create the s minus half here, minus half plus half. Then you take out the minus half, you form the e. E 102 t a opposite sign. So what is that? You have 2s plus half minus 3 over s squared minus 25/4. Okay. So for the denominator, expand, simplify, then you separate the function and proceed with the inverse Laplace. Okay, so when you expand, you have 2s plus 1. Okay, cancel out the 2 plus 1, 1 minus 3, you have minus 2. Okay, then separate. S and 2 over s squared. Okay, so what do you get for this? 1/2. Factorize the 2, and this is hypercos. Hypercos, your A is 5/2t. Okay, minus this one. 4/5. Okay, factorize the 2, and then you need the 5/2 here. Okay, insert the 5/2, and outside will be 2/5. This will be hypersine 5/2t. Okay, meaning that this is 4/5. And give the answer directly 4/5 if you are able to see it through. The given answer in the slide is in the form of exponential function because I solved it using partial fraction. If you solve using partial fraction, you will get the same answer for the slides. But actually, the answer in the slides is different with this one. Okay. Because the function of hypercos and hypersine, actually they have the formula in terms of exponential function. Okay, number 3. Okay, number 3. Exponential. This one. 2x minus 2. Here, 2x plus 2 times half, which is 1 minus 3. Okay. Number 3. Of course, transform every single terms. But we have to know how to use it. Okay, Laplace transform every terms.
At least it's right.
Double prime from s squared. X in s minus s x in 0 minus x prime in 0. Okay, plus 8 x prime. X prime, that's mean s power of 1 s minus no more s, but no case of x 0 plus 15x. This is not a derivative. So x in x equals to Laplace 0 is 0. Okay, then substitute the given initial values. X 0 is 2. X prime 0 is negative 3. Okay, minus 2s minus plus 3 plus 8 s x in s minus 2 times 8 minus 16. Need to be careful with this because normally student make careless mistake here. Forgot to multiply the 8.
Inside multiply the 8%.
Yes, multiply. You have to open this bracket next. Okay, so factorize. And simplify 2s, move the negative 2s to the right. 3 minus 16. This means minus 13. Minus 13, when you move, you get plus 13. Okay, the square. S plus 4 square minus the square of 4, 16 plus 15. So you have a minus 1. So now we want to apply the inverse Laplace to get a final answer. Okay, inverse Laplace. So we change the denominator into this s plus 4 squared minus 1. Okay, so when you change this into this form, this means the next step, we want to take out the plus 4. Okay, when you want to take out the plus 4, check denominator. Is there any s? If yes, create the s, s plus 4. 2s plus 13. Okay, 2s plus 13. So this one, s plus 4 minus
Why here it's minus 16? Why it's not plus 16?
minus, always make the square of this.
The square of 4.
Yes, the square.
The square of 4 is 16.
16.
Minus this square. That's, so if it is minus minus, plus 16.
No, this will always be minus. Always be minus the square of this value, and then continue here.
أنا عارف بس بس لو كان ماينس ماينس وصلت صح؟ لو طلع معك مثلا
Okay, now we can take out the plus 4. Take out the plus 4 to form x function negative or c. So 2s minus 4 plus 13. Expand, simplify. Okay. No more plus 4. S square minus 1. Okay, expand, separate, first last. Okay, what is the time for your attendance? Okay. So we have 2s, okay, expand, minus 8 plus 13. So plus 1. Separate. After separate, then you can see what is the final answer. So what is this?
Take the 2 outside. That's either
2 either cos t. A is 1. Okay, this is your a squared. So a is 1. This one, 5 hyper sine p. Okay, you just need to factorize the 5 because a squared is 1, so your a is 1.
So it is 1 over s squared.
Yes, 1 over s squared.
Yeah, we take the 1 above, it's 1 over s. So
Because a is 1. A is 1.
yes, 5 outside and 1 is above.
Yes. Yeah. 5, you have 1.
1 over s squared
Minus 1.
minus 1.
A over s squared minus a squared, but your a is 1 now.
Yes, so t is 1 over s squared, right?
So t here is a sine, hycosine at, right? At, your a is 1.
I know, but t is 1 over s squared.
T,
Yes, from the Laplace transform. What is it? T equal 1 over s squared
1 over squared
or 1 over s?
squared.
Yes, so minus
This
1.
is inverse Laplace of 1 over s squared. This is s squared minus 1.
I know, so minus 1, but it's not. That's the minus.
If you have only this 1 over s squared, and you get t. Because this is s squared only without any constant outside.
The minus 1, what is it?
There's no minus 1. Minus 1. This one inverse Laplace of this equal to minus sine at. Right? These are two different formulas.
Because I'm forgetting there.
More questions? Okay, now we look at the next one, number 4. Okay, number 4.
Okay, let's say we'll look into
Laplace transform all of the terms, but now your right hand side function is no longer 0 as question number 1, 2, 3. Now this is y. Okay, y double prime. So you have s squared, capital Y in x. Okay, now this is y. So minus s, lowercase of y is 0, and y prime is 0. Okay, this is y, this is not a derivative, so we just put the capital Y in x. What do you get for the right hand side function? Laplace e negative 1, negative t is 1 over s plus 1. Okay, plus 1. Okay, now substitute y 0, 2, y prime 0, 1. Okay, factorize the capital Y in S and move those without Y in S to the right.
On this one is not.
Okay, move the minus 2x minus 1 to the right, then you have this. Okay, and what we want is y in x. Okay, y in x meaning that all three terms divided by s squared plus 4. Okay, all of them. Divided by s squared plus 4. So when we want to get a final answer, we have to inverse Laplace. Okay, inverse Laplace these three terms. Okay, this two shouldn't be a problem, but this one, how to inverse Laplace this?
Oh, yes, separate. Separate.
Separate means
For two.
what's the name of the method? Okay, convolution theorem. You can use convolution theorem or partial fraction, right? Because from this question, it doesn't mention that you have to use or you must use convolution theorem, so you are free to choose. So either convolution theorem or partial fraction. So if you use convolution theorem, meaning that you will separate this into this one, right?
I said that.
So from the inverse Laplace, you get something like this. You get something like this. So meaning that later on, when you change one into u, that one into t minus u, you have to integrate the product function that contains exponential function and sign. Do you still remember how to integrate the product function of something like this? X cos 2x. Do you still remember how to integrate this? We are still using the tabular method, but we have to use the horizontal arrow that contains the integral sign. So that we get this back and we combine the right-hand side function with the left-hand side function, then we divide the coefficient function. So the steps is quite long. The step is quite long. Because this is not polynomial. So this is convolution theorem. So if we use this one, I would recommend you to use partial fraction compared to convolution theorem. Okay? Because convolution theorem it involves the integration of case 3. This is considered case 3. Okay? Exponential with cos or exponential with sine. Okay, but still you will get the same answer. Okay, you get the same answer. But in terms of the working, I think partial fraction will be easier. Okay. So we use partial fraction. Plus 1 s squared plus 4. Okay, so we separate this. So this is power of 1. So here is a constant. This is power of 2. So here you must have an x, dx, then plus c. Okay, partial fraction. I think all of you know partial fraction, right? You have learned during secondary school. Oh, this is not secondary school. Form 4 or 5, something like that. Okay, it's okay as long as you have learned this before. Now we want to compare. Okay, compare. Basically, this is something like this. This one we want to combine into one. If you want to combine into one, meaning that A has to multiply to this. And this one has to multiply this. Correct? This is the way that we combine two functions into one, right? And now we are comparing the denominator function. That's why you get this. We just compare because their denominator is the same. We just compare the denominator. Okay, this is partial fraction. Normally we skip this one, right? If you still remember what you have learned, normally we skip this one. From here, we just jump to this one. 1 equals to A times this plus this one times this. Okay. We want to find the values of A, B, C. So we just choose a value which is convenient to us to find for the A, B, C. So first, we will choose S equals to. What if we choose for S value? -1. Why we choose -1? Because when S is -1 plus 1, you get 0. 0 multiplied to this, that means this is gone. So we have only this. So when S is 1, then this means we substitute S equals to -1 into all S. Okay, so on the left we have 1, on the right we have -1 squared is 1. 1 plus 4, we get 5A. But this is already 0 when S is -1. Okay, this is the purpose why we choose S is -1, because we want this to be gone. We want to have one unknown in one equation. We have only one unknown in one in the equation in order for us to get the value directly. Okay, then we get A. So next, what will you choose? We will choose 0, okay, because of this. When S is 0, that means B is gone. Okay, when S is 0, that means B is gone. S is 0, meaning that you substitute all S by S equals to 0. So on the left, we have 1. On the right, 0 plus 4, we have 4A. Here, S is 0, that means this is 0. We have only C. C times S is 0, 0 plus 1, 1. 1 times C plus C. So with the value of A, you get C. Okay, so your C is 1 minus, C is 1 minus 8. Okay, 1 minus 4A, which is 1/5. Then we get C. Next, we want to find for B. So since this is positive value, okay, this is positive S squared. This is positive value, this is S squared. Okay, so there is no such a value where we can make this to be 0. Okay, no such an S. Okay, so what we choose, you just choose a small value, 1. Just simply choose the value because we have already got AC. Okay, we can get a B later. So when S is 1, okay, simply choose one value. So substitute all S by 1, you get 1 equals to 5A. S is 1, you have B plus C. Again, this is B plus C. S is 1, you get 2. So 2 times B plus C, that means 2B and 2C. Okay, then from here you can get the C.
I guess our page, we got the C.
Yeah. Continue here. It's B, sorry, B. We're going to get B. So 2B is 1 minus 5A and minus 2c. 1 minus 5a minus 2c. Okay, 1 minus 1, then minus 2 over 5. You have this. Then we get our b as negative 1 over 5. Okay. And substitute this a, b, c back into the partial fraction. This one you will get a is 1 over 5. Okay, 1 over 5 x plus 1. B is negative 1 over 5 x plus
1 over 5.
1 over 5 over n squared plus 4. Okay, so you get this. Then you go back to the st just now. Your st is inverse Laplace of this function, right? So this function is changed into this now. Now you still have 2s at 1 time. Okay, so now you can continue to get the final answer.
Take 1 over 5 outside.
Yes. Factorize 1 over 5. So this is
Cosine. Science.
cos and sine. You must have a square. So this is e negative t. Okay, this is s minus negative 1. Then this one. Okay, this one we have to separate this into 2, right? Okay, separate this into 2. So the first one, this part,
That's a hypercube.
you have minus 1 over 5. This one, what do you get here?
Hyper.
Hyper, this is plus, minus, this hyper.
Hyper sign.
This is not minus. Hyper, if hyper, this is minus. So this is cos 2t.
Yes.
Okay, the one hyper, it will be s squared minus a squared here. The one with hyper. Okay, and then this part,
The 1 over 5.
take out the 1 over 5,
Sine.
and we need,
Sine 2t.
no, we need a value here.
Yes.
What's the value?
2.
We need a 2. 2 means that outside 1 over 2.
1 over 2.
Then only sine 2t.
Yes, right?
Then here,
On.
plus 2 cos 2t. And this one, we need a 2 here.
1 over 2.
1 over 2 sine 2t. Okay, so this one you can combine with this one combine with this. So the one with cos 2 minus 1 over 5. 2 minus 105, so you get a 9/5 loss to t. Then 1/10 and 1/2. 1/10 and 1/2. So 6/10. 6/10 means 6/10 means 3/5. Any questions?
It's all one question, right? It's all one question. All is that?
Okay, now we look at question number 5. Okay, this question number 5, if not mistaken, I take from past year question. Past year or assignment? Assignment last few years, I can't remember. Okay, but this is the level. Okay, this is the level of difficulty for the past year. I think from past year, if not mistaken. I really remember when I took this. Okay, so this one, if you look at this question, there are 2 parts. Okay, part A, prove that Laplace transform this function equals to this. Okay, so prove it, and you are given the final answer. And it's that you just Laplace this as usual through the formula from the table, Laplace table, and this will how to Laplace transform for this. This is a product function with t.
Integrate, right?
Derivative rule. You have to apply the derivative rule. Okay, then you get this one. Okay, next B. Okay, you are given this with the initial values. Then solve the problem by using Laplace transform. Okay, solve this using Laplace transform with the result from part A. Okay, this sentence with the result from part A means that after you solve this, and at the last part, when you want to apply the inverse Laplace to get the final answer, you may use this. You may apply this to help you to get the final answer. This is what it means with the result from part A. Means that this part will help you later. Okay, this part will help you later in the part of inverse Laplace to get a final answer. Okay, now we proceed in 5A first. Okay, 5A. Try to Laplace transform the function, the given function. So we start with this one. Okay, we start with this one first. So we Laplace transform the t cos 2t. Okay, according to the formula, you have to identify the n. And the t n, okay, plus t n f t equals to -1 to the power of n and ds n f s. Okay. So you have to identify the n. N is 1. N is 1. So your ft is cos 2t. Okay. So here, if n is 1, you have a -1. And then d over ds, you need to differentiate for one time. And you need to differentiate the fs. To get the fs, you need to Laplace transform this f. That's me from here. What is your fs? S over s squared plus 4. So this one, you put it here. So differentiate. You have s at the top and at the bottom, so you need to apply the quotient rule. Okay, bu prime minus ub prime over b squared. Differentiate this function. Here, b u prime minus u b prime. What is your b prime? 2x over b squared. So expand, simplify. S squared plus 4 minus 2s squared. That means 4 minus 2s squared. Okay. 4 minus s squared. Okay, s squared minus 2 squared. You get a negative s squared. Okay, and you can insert this minus into here, so that you have s squared minus 4. Then you can continue this one, Laplace this. Okay, Laplace this one where you have already found this, which is this one. Okay, continue from here. This one, we want to prove that this is equal to this. Okay, so the question is prove this one equals to this. Yes, you have Laplace this one, and then minus this one. That's mean you have got it here. Okay. Okay. So from here, Laplace, this one, it starts from the left-hand side. So that means the Laplace, this one, minus Laplace, this one. Then try to Laplace this, minus this one, you have already got it here. Laplace half sine 2t. Okay, factorize the half. Laplace sine 2t is plus 4. Okay, minus 5. This time what is that? 4 minus, is it 4 minus s squared?
X squared minus.
S squared minus s squared minus 4 over s squared plus 4 squared. Okay. Then cancel out a few here. You have this one. Okay, but we want to prove this. If we want to prove this, so meaning that you have to combine these two into one. So how to combine? This is not the same, right? You need to multiply the s squared plus 4 to this top and bottom. Multiply the s squared plus 4 to the top and the bottom so that their bottom functions are the same. So this one multiply s squared plus 4 minus second function. Okay, simplify. S squared minus s squared, no more s squared. 4 minus minus, we get a plus 4 plus 4, 8. Okay, so this is 5, 8. We have done proof that Laplace of that function equals to this. Okay, so far any questions? If no, B, we can find B. Okay, then we have to solve the differential equation using Laplace transform. Laplace transform this. Does it hurt? Does it hurt?
Yeah.
Yeah.
No.
If you understand all the concept, I would say, this is still acceptable. Still acceptable because you have learned how to use the derivative properties, the first translation, inverse, and also the Laplace and inverse Laplace. So by right, it shouldn't be a problem for you to solve this. Okay, by right. Okay, but actually I can teach in a much simpler way without giving such a complicated exercise during the class time. Okay, I can skip this one.
No, don't skip it.
But I skip this one when you face something like this, the question something like this, you feel the culture shock. That's why I still show the working of such a
Don't skip.
question during the class time. Okay. Okay. So I think left hand side shouldn't be a problem. Right hand side. How do you Laplace transform the right hand side function? First translation. Okay, first translation. Okay, we solve this one first. Okay. For the first translation, the formula is EAT FT Fs minus A. Okay, first translation. Meaning that you have to identify your A and FT. Okay, so this is Fs
That's one.
plus 1. Then your FT is FT is sine to Q. Then we need the Fx.
2 over sine 2.
2 over S squared plus 4. And what we want is this one.
What's the first? How we get the FS?
Laplace. Why we want to find for this? Because we want this. We always refer to the formula. We want this, and this comes from here. Okay. Then we can continue back with this one and just put this one on the right side here. Okay. So you can start to S squared capital Y S. Laplace transform every single terms here, and then right hand side you write this. Substitute the initial values, simplify, factorize, rearrange, inverse Laplace. Okay, so on the left you have -1, so just move this -1 to the right. +1. Okay, so this one we need to move to the right. It means that these two terms divided by this. Okay, these two terms divided by this. So this one, you can try to complete the square. Okay, try to complete the square. Here, s squared minus plus 2s plus 5. Okay, so you have s plus 1. Okay. Minus
minus
1, the square of this.
So it's this one.
Plus 5. That's 4. So that function, this function is actually same with this one, right?
Just the same.
Okay. Now they are the same, meaning that when you move this to the right, this will be s plus 1 plus 4
Plus 1 over
plus
S plus 1.
1 over s plus 1 squared plus 4. Okay, so now we want to inverse Laplace. Inverse Laplace to get the y in t. So what to do? What to do? We want to get a yt. How to solve the inverse Laplace of this? What you need to do? Any idea? What to do next? Any idea what to do next? Huh? What to do next? Huh? Whenever you see the s minus a bracket squared, what to do? First translation. We take out the plus 1, right? We take out the plus 1 first. So there's no s here, no s here. Okay, so at this moment, we can take out the plus 1. So take out the plus 1, you get an e minus t. Okay, inverse Laplace of 2 over s squared plus 4 squared plus 1 over s squared plus 4, right? All right, after you take out the plus 1. Then now, what to do next? How to solve this? How to solve this? How to solve this? Huh? Huh? Partial fraction? Partial fraction, this is repeated root. If you try partial fraction, you will still get this back. Because this is already factorized for you, okay? You still get this back. Okay. Because this is a repeated root one. Okay. So you will still get something a constant over this one. So how to solve this? Anyone? Any idea? Convolution? Yes, convolution can be solved. Convolution can be used to solve this one because this one you can break this into 2 over s squared plus 4 and 1 over s squared plus 4. But do you still remember the sentence, the question, the result from part A?
Yes.
What do you have from part A? From part A, you have this. Minus t cos 2t equals to this one. So this means, okay, this means inverse Laplace of this function equals to this one, right? From here, Laplace A equals to B, meaning that inverse Laplace of B equals to A. This one is the same as this one, right? It's just that this is 8, what we have is 2. So just factorize the 4. You just factorize the 4, then you will have this one, right? 2 over s squared plus 4 squared. Factorize the 4. So you have a 4 here. You move it to the right, then you get this one. So you don't have to don't waste your time on solving the convolution theorem while you have been given the convenience from part A. Okay, so we have got this. And this one is simple. So E negative T. Okay, Laplace this one. Okay, just copy this. Finish. Plus this one. Plus this one. So inverse Laplace of this one, you need a 2. So you divide the 2 outside. This is sine 2t. Okay, and sine 2t, you can combine. Okay, you can combine into 1. So 1 over 8 plus 1 over 2. Okay, any questions? So when you see a question, something like this, okay, with the result or by using the result from part A, highlight the sentence. Highlight the sentence. Okay. And when you totally has no idea how to solve it, look again at your question, and you will see one take note there to remind you that you can use the result from part A for this kind of question. I mean. Okay. So today, okay, I will stop the class here because for section 2, I stop here. So for this afternoon or this afternoon, okay, if you want to join, you can come to BK 3 to 5, okay, 3 to 5. But if the questions from students are not much, then I may interview the revision class. Okay, so it depends on if you have any question, just bring it to BK3 this afternoon at 3. And you can also join online class. If you have the questions, it's better for you to physically. Okay, so see you this afternoon.